Welcome back to lesson 4.1, ratio, comparing two quantities. This is the second video that I'm making for you as students. The first video was really the basics of ratio. The second video is about the word problems located on the back of lesson 4.1. So I want you to turn your papers over, take a look at numbers 10, 12, and 13 with me now. Number 10. Mr. Kahneman buys 1 2-pound lobster and 1 pound 4 ounces of shrimp. Find the ratio of the weight of lobster to the weight of shrimp. Well, I know that order matters. I know that I want to code here. The first thing they're asking for in the ratio is the lobster compared to the shrimp. So I'm going to write with my mathematical shorthand L to S. Lobster gets the L, shrimp gets the S. Well, what measurement goes with a lobster? If you look up here, lobster was the 2 pounds. So I'm going to write down here 2 pounds. Notice I'm also using a label right now, pounds, to make sure that I don't get confused about what units we're measuring in. Next up, shrimp. Well, shrimp is over here. It says 1 pound and 4 ounces of shrimp. So I'm going to label that 1 pound, 4 ounces of shrimp. Now, you could say there's my ratio, but my concern would be this bold print text at the top, which says, show your work, and give all your answers in simplest form. I can't simplify this ratio yet. The problem is, I don't have the same size units. So if you remember, we always want to start with the larger units, if your pen will let you. Oh, this is a terrible time to have this happen. There we go. Start with the larger units and convert them into something smaller. Well, I know for a fact that pounds are larger than ounces. So how many ounces are in a pound? I hope you're looking at your conversion chart on page R8, which is a reference page in the back of your planner. And you will find that there are 16 ounces in a pound. Oftentimes that reminds me of children's birth weight. If you know how much you weighed when you were little, you can kind of remember oftentimes that there were 16 ounces in each of those pounds. All right, here we go. 2 times 16 gets me 32, and I'm now in ounces. But on the other side, I have a combination of pounds and ounces. So could I take these pounds and turn them into ounces as well? Yes, great idea. I could take this 1 pound and I could multiply it times 16. 16 ounces times 1 pound. Well, 1 times 16 is definitely 16. That is a piece of the puzzle. But remember, I have these 4 ounces extra. So I'm just going to kind of notate it this way. It looks a little funny at the moment, but I think it will be okay in a moment. Let's see here. 32 ounces compared to 16 ounces, 4 ounces. Well, isn't there a better way of writing this? Couldn't we clean something up a little bit? I hope you're noticing that on the right side, these units match. We might as well put them together. It's like adding 16 ounces and 4 ounces more. So your next step is probably going to look like 32 compared to 16 plus 4 is 20. Notice it's okay, I took the units off because we're now working in ounces. Well, this looks a lot better. At least I have a ratio with similar measures. The problem I have here is that it's not in simple form. So your next step is to think of the greatest common factor. I'm really going to leave you to do this step because I don't want to just give you answers and give you a shortcut on how to get your work done. So maybe you needed my help to get to that point, but now dig into your multiplication charts if needed. Think about what divides into 32 and 20 nicely. If you have to divide a couple times, please do so, but get me to the lowest terms or simplest form of your ratio. Next, we'll take a look at some oatmeal bars, which sounds really yummy at this point of the day. Number 12 talks about Hamza and Liam. They are baking 108 oatmeal bars. That sounds like a total. That sounds to me to be kind of important. I'm going to stop right now, underline it, and write a capital T above it. That's how I show that I found something that represents the total. It says Hamza makes 20 more bars than Liam. Find the ratio of the number of oatmeal bars Hamza bakes to the number of oatmeal bars Liam bakes. Well, I have the privilege of using multiple colors here, so I heard they want Hamza compared to Liam in a minute. So in a moment, I'm going to think about Hamza to Liam. Use kind of my mathematical shorthand over here to make sure I give you an answer in the correct format. Well, I think a bar model would be very helpful. I'm kind of visualizing that we have two different bars, one for Hamza, one for Liam. Well, it says Hamza makes 20 more. If he makes 20 more than Liam, they're basically telling me his bar must be longer. You go, Hamza, lots of oatmeal bars. Liam's bar, well, I don't know how long it is, but I know it's not as long. He didn't make as many oatmeal bars. There's something of interest here. If Hamza really made 20 more, wouldn't that be the extra portion on his bar? Wouldn't it be like karate chopping this right about here, hi-ya, and saying, hey, there's a 20 sitting here. This looks pretty good to me. Now, what about that total that we talked about a minute ago? That 108 oatmeal bars. Is that just Hamza's? No. Is that just Liam's? No. That is for the two of them combined. 108 is the total. Well, I want you to think about how you're going to get there. Every year I have students take that 108 and split it equally among Hamza and Liam. But I have to caution you, I don't think we can do that because of this 20 extra idea. So what would I have to do to get rid of those 20 extra? I said get rid of. That almost reminds me of an operation. In math, getting rid of something is like subtraction. You're going to want to take that 20 extra away and see what's left. Well, once we're down to that point, wouldn't we be able to split what's remaining into their two bars here? Figure out half of what's left for Hamza, half of what's left for Liam? That's exactly the direction I want you to go in. I'm going to stop here as well. I'm going to let you try to finish out the last steps, but I do hope that my bar model was a help to you. Okay, and again, don't forget your order matters. Hamza to Liam in a minute in simplest form. All right, next up. 1 pound of swordfish costs as much as 1 and 5 tenths pounds of salmon. Mrs. Ortiz pays $39 for 2 pounds of salmon and 3 pounds of swordfish. Find the ratio of the amount of money Mrs. Ortiz pays for the swordfish to the amount of money she pays for the salmon. Well, we're comparing two different things this time. Here I'm looking for swordfish to salmon. So just digging into that question one more time, what order am I going to answer in? Swordfish to, oh my gosh, they start with the same letter. So I'm going to keep the swordfish in SF, that's pretty safe, and my salmon just in S. I think it will work. So in a minute, we're going to consider swordfish to salmon in that order. Well, could we try bar model again? That seemed pretty useful last time in number 12. So 1 pound of swordfish costs as much as 1.5 pounds of salmon. That's like saying I'm going to compare my swordfish to my salmon. My first bar, I'm going to show you 1 pound of swordfish. I'm going to work with just a stretch here and see what we think of that. This is the same cost as 1 1/2 or 1.5 pounds of salmon. So if I make this bar the same length, this isn't just 1 pound of salmon though, this is 1 1/2 pounds. So it's 1 whole pound plus a half more. 1 whole pound plus a half more. And notice the length of these are the same because their cost is the same at that point. Well, wouldn't it be really nice if I could figure out how to split this bar so it looks similar in parts or pieces to this one? If this is 1 whole pound and a half more, couldn't I kind of karate chop this here and show you that 1 whole pound is the same as 2 halves plus a half more? 3 halves is the same as 1 1/2. And then if this bar is truly the same length and the same cost, I could definitely chop these here just so that I'm keeping my parts or my units the same. Well, the second sentence comes into play right now. Mrs. Ortiz pays $39. Ooh, I just saw something. I like to underline this one. That sounds like a total. But I can't get the T to right. I just found a total for everything she's going to buy. I'll save that for in a little bit. She's going to buy 2 pounds of salmon. 2 pounds of salmon, and I'm only using 2 lines to code that because I use 2 lines in my ratio. So I have 1 whole pound here and a half more. She bought 2 pounds. So how much am I missing here in my bar model? To get to 2 whole pounds, she's missing a half pound more. So I might kind of sketch this in here. Now I see that she has 1 pound and 1 more pound here. She has a total of 2 pounds of salmon. Good. All right, what about this 3 pounds of swordfish? I'm going to use 1 line for that because swordfish had 1 line in my ratio. Well, it says here that this was 1 pound of swordfish. But she's buying 3 of them, so I'm going to kind of sketch on here. There's a 2nd pound, there's a 3rd pound. And if each pound could be split into these thirds, like we did earlier, I would have the same size units to consider for each bar model. Oh, we're so close. My bar model is complete, but I'm missing an important label. I save this for later. I oftentimes do. The total. Well, the total is $39. That was not just the swordfish. That was not just the salmon. That was both of them included. So I'm going to show $39 over here, going with both bars. Well, the next step would be to figure out how many little tiny pieces we have all together, and that would really help me figure out how to split this 39 into smaller pieces or into equal parts. So you're kind of thinking 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 equal pieces. That's what I want to split this $39 into. I'm going to split this $39 into 13 pieces or parts. Well, already I'm seeing, I know 13 goes into 39 nicely. I'm kind of excited about that. But in a second, it says, I want the amount of money Mrs. Ortiz pays. I actually want the real thing, the real amount of money. I was thinking about simplifying this a minute ago. Would that be wise? Not really. I want an actual amount. Do not simplify this one. That's kind of weird. We've been saying simplify, 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 but if they actually want to know how much you need to put into the cake or how much you need of that money, they're not actually asking for a comparison in simplest form. They actually want the actual amount. We're going to have to handle this a little differently. So I hope you're representing or recognizing how much you'd find in each little tiny unit. You could then show that in each little tiny unit here in your bar model, and I hope you're getting close to an answer. I would remind you they're giving me words. We might want to give them word form back. And I also noticed that they're measuring in money. Ooh, that might be helpful to label here in this case, because again, they're actually asking for a total amount. I mean, an actual amount, not a simplest form. I hope you found the second video somewhat helpful. I hope that your bar models are getting better as we go. And with that, we're going to stop here with our first lesson in ratio.